Right, welcome to the video. This time we're going to be looking at another thing we can use Pythagoras for, okay? And that thing we can use it for is to work out the distance between points on a coordinate grid. Okay, so if I draw just a wee example here, we have our coordinate grid, okay? And I've got point A here and point B. Okay, and I want to work out the distance between these. Okay, let's pretend I drew a straight line now, and let's call that D, the distance between them. Okay, a second, let me just move that over. Okay, but you can see here that what I've actually drawn, if I went like this, okay, would be a right angle triangle. Okay? Yeah? And if this was a point here, it would have coordinates x1, y1, and up here, this would have the coordinates x2, y2. Okay? So we could use Pythagoras to find the length of this side, okay? You don't really need to know how you do that, you just need to know the formula, okay? But we'll go through how you get that formula from, just because it might help you understand it and help you remember it, okay? So, let's say we're trying to find that side, okay? We'll have d squared. And remember, your normal Pythagoras formula is one side squared plus the other side squared, okay? So, how long is this squared, okay? What is the size of this side? Well, we know it starts at a value of x1 here, and it finishes at a value of x2. So its length would be x2 take away x1 squared, okay? If we look at its height, well, it starts down here at a height of y1, and it finishes up here at a height of y2. So the height of just that side then will be y2 take away y1, and we square that. Okay, so there we've got the hypotenuse squared equals one side squared plus another side squared. And so if we want to work out the distance, it's just the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? And that's how we'd work out the length of this side, right? So let's have a look at an example of that, okay? We're just going to do one little example of this in 2D because we also want to look at this in 3D, okay? So let's come up with some numbers then. Okay, so I've added some numbers to these coordinates now, so we can see how we'd work it out if we had actual coordinates. So let's say the question then was asking us, what is the distance between the point 22 and the point 65, okay? Well, we'd use this formula, and we'd just sub in, okay? So we'll say d equals the square root, and then we'll just sub in. Okay, so x2 is 6, x1 is 2, y2 is 5, y1 is 2. So we've got d equals the square root of 4 squared plus 3 squared. So d equals the square root of 16 plus 9, d equals square root of 25, so d equals 5. Okay, you wouldn't necessarily have to show every one of those steps of working, but there we've used Pythagoras and we've worked out that the distance between point A and point B is 5. Okay, and so that's how we'd use Pythagoras here, okay? We can do exactly the same, pretty much, if we extend it to 3D, okay? So if we think about the distance between 2 points on a three-dimensional coordinate grid, okay? Now, we haven't done a lot of work with 3D coordinate grids before, okay? But what we should know about them is that on a 3D grid, we still have an X and a Y coordinate, okay? So we still have going along, going up, but we also have a Z coordinate, which is how far forwards or backwards, okay? So, just like up here, we said the distance there for 2D. If we were looking at this in 3D, our distance then would be the square root of x2 minus x1 all squared plus y2 minus y1 all squared, and then we just add in a bracket for the z's, plus z2 minus z1 squared. Okay? And that's it. We've just added in that extra bracket for the z's, and then you follow it through exactly the same way as you would before. Okay? So let's have a look at an example of this then. Okay, so I've written down a question here. Point A is -2, 3, 4, and B is 3, 5, 7. Find the distance between them, okay? And just because we're not really familiar with the x, y, z coordinates, I'm just going to label on. This is your x, so your first is still your x, the second is still your y, and then the third one is your z, okay? Let's label them x1, y1, and z1. Here, first one is still your x, second one is still your y, and the third one is still your z. Okay? Now, unfortunately, you don't get given this equation for the distance between the points, okay? You need to remember that, okay? So that's why we'll do practice of it. But it is just your Pythagoras, okay? So it's your x is taken away from each other squared, plus your y is taken away from each other squared, plus your z is taken away from each other squared, okay? There's a definite pattern to it. So let's fill out this formula then, okay? Distance equals the square root, can we see this? Yeah, we can. The square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay, and let's sub in, okay? Simple as that. Sub in the information from the question that we've already labelled. So, x2 is 3. Oh, sorry. x1 is -2. y2 is 5. y1 is 3. And then z2 is 7. And z1 is 4. Okay. And let's work that out then. Okay. So, equals the square root of 3 minus -2 is 5 squared. 5 minus, oh sorry, I forgot the square there. 5 minus 3 is 2, so 2 squared. 7 minus 4 is 3, so that's 3 squared. So that means the distance equals the square root of 25 plus 4 plus 9. So D equals square root 25 plus 4 is 29 plus 9 is 36. Sorry, not 36, 38. Okay, and then we could do this on our calculators, okay, which I do not have. Yes, I do. Okay, so square root of 38 is 6.2. Okay, and then that we get the distance between the points is 6.2. Okay, so as you can see, the actual maths is no harder than anything you do for normal Pythagoras. Okay, it's just remembering you've got your x, your y, and your z coordinates. Okay, so I'll set you some questions on that. As usual, if you have any questions or problems with it, please get in touch. Hope that was understandable. Thank you for watching.